Hey, look, here we are. It's time for MakeCode Live with me, John Park. Thanks for tuning in, everyone. We are now live out on Mixer, on YouTube, I think maybe Facebook and some other places. Twitch, pretty sure Twitch got the message. So I want to thank you all for stopping by. And let's see, what have we got going on today? I thought we would take a look at there was a request from a viewer about figuring out how to have their game enemies follow them inside of MakeCode Arcade. They actually had followed the shark tutorial from a few weeks ago and wanted to add to it some enemies that would follow them down hallways. So I thought we would do something along those lines and show a way to do an enemy follow inside of MakeCode Arcade. So that's the plan for today. Let's see, before, however, we get started with that, I wanted to show one of our MakeCode team member videos every week for the last few weeks. I've been inviting a guest member from the Microsoft MakeCode team to come on and talk about some new features or aspects of their work or history of MakeCode or where MakeCode is going. So without any further ado, here we go.
Hello everyone, my name is Cristo and I'm an engineering intern on the MakeCode team. I'm here to show you all a new feature in the works. So let me just start off by typing some code. So if you can see, we get this little pop-up that tells us we have an error in our code. So we can open it and we could also close it. But let's open it to find out what our problem is. So in this case, we're given information about the location and some more details about the error to help us fix it. So let me just click on this and we're taken to our error. So in this case, this is an easy fix, so I'll fix it. So now our error is fixed, so it disappears. I'll write some more code just to show some more errors. So now we can see that we have 3 errors in our code. Let's open them up and fix them. And also you can see that we're given more details about the error that can help us fix it, so it can improve your programming experience. And now, as you can see, as we fixed our errors, they disappear from our error list. Okay, so now this code looks pretty much good to go, so let's give it a run. Okay, so I intentionally added an error here that occurs when I press this A plus B button. And here we have a runtime error that caused our program to crash. So here we display stack trace, and we also give you the option to start a debug session. I'll click the start a debug session, but that's pretty much it for me for now.
All right, that is excellent. Very exciting to see continued development of features in MakeCode that make it incredibly helpful when you're coding in general or when you're learning to code particularly. But I think that sort of help inside of the editor is a real benefit to anyone. So I'm excited to see that feature. Thank you, Christo, for putting together the video for us. We appreciate it. Okay, so let's get into MakeCode Arcade now. So I've got my session open here, and what we'll do, I'll show this both in the simulator as we work on it here in the web page, as well as on hardware. I have I can flash down to this for a second. Let me let's see if if we can switch cameras over to this piece of hardware. So this is the Adafruit Pi Gamer, and it's one of several hardware handheld gaming systems that you can use with MakeCode Arcade. Some of my favorites are the Pi Gamer, the Pi Portal, also from Adafruit, and the Kitten Bot from Meowbit. I think those are great handhelds that you can push your games to from MakeCode Arcade and then play them with real hardware. So we'll come back to that once we have our game demo put together. So let's take a look now in the MakeCode editor here. So what we'll start out with, I've got, if you recall from the last show, I talked about some of these new features in beta. So I'm using the arcade.makecode.com/beta version, and that includes this ability to do code folding or block collapsing, however you want to call it. And I can do that by right-clicking and choosing collapse blocks, or I can click on the down arrow to reopen my block. So that makes it a lot easier for me to organize things and keep the clutter down. So what we'll do is we'll start out with a little tip here that I have. As I have been working on this code, one of the things I wanted to do was be able to turn on and off features as I go. So you'll see the very first thing that's happening in my setup here in this onStart block is I have these enable variables that are all set to false currently. And so I've created those so that I can turn features on and off. And 1 second, I just want to pop open my Mixer window so I make sure that I'm keeping an eye on that. Where did Mixer go? There we are. Hey. Hey, Jack in the Box. Yes, Pi Gamer is so much fun. And by the way, I loved the game that your child posted earlier. Very nicely done. People are sharing their games and the games that their kids are working on inside of the Mixer chat, so go check that out. All right, so with these variables, let's zoom in here. I have things like a variable which I went and got out of the categories here: variables, make a variable. I created a variable and I named it enable tile map, and then I grabbed out of the logic blocks down at the bottom here. There's a true and a false block, and those can turn into each other through a drop down. So if I turn that on, it's going to enable this variable. It's going to set this variable's value to true. So what does that do? Well, if we scroll down to the next sort of section in my startup code, I have this if statement that says if enable tile map, which is the same thing as saying if enable tile map equals true. You can actually do it that way. If you go into the logic blocks and grab this comparison, and let's take enable tile map, put it in there, drop that into this box, and then I'll duplicate one of these false blocks and set it to true. Okay, so let this thing restart over here. Oh, no, it doesn't like me now. What did I break? Okay, maybe I shouldn't do it that way. But the way that I've done it, it means that. It says if enable tile map is true. And so that can be confusing at first, but that's what that means, is it's checking to see if that variable right there is set to true. So if I go and change this, then it will run all of the code that's inside. And that's what we saw pop up a second ago, which is there's now a background color and there's a tile map in here. If I expand this, you can see a piece of the tile map. And then if I click on that little tile map block to open it up in the tile map editor, you're going to see a couple things here. First of all, the tile map is larger than the screen. So I set it to be this ratio that is probably 4 times wider and 2 times taller or something like that than the screen. I forget what the relationship is between these blocks and screen blocks, but this is a 32 by 16 tile map. However, you notice that even though it's only 32 tiles wide, that's much wider than the screen. I think there might be 16 pixels per tile. So we have 16 times 32 is the pixel width of this. And so you can create your tile map by simply using these available tile sets. So I'm using forest tile sets here. So if I want to go and change, let's say, the color of some of these blocks, it's not even the changing the color, it's changing the whole graphic. I can go in here and paint in new types of maps. I can also go in and let's take a look at if I place, say, a hedge here. One of the things about a tile map is that it prevents the character from walking through sections of it if you want. So what I'm going to do is I'm going to turn on this switch up in the upper right that says Show Walls. And what you'll see is, as I toggle that on and off, you can see anything that gets lit up sort of reddish, that's somewhere that I've placed a wall, which means that the characters and the enemies won't be able to go through it. Same with projectiles. So you can block things with these walls. And so since I added a section here that should probably have a wall on it, I'll go ahead and switch from drawing the graphic tiles to drawing these essentially bounding box or collision tiles with this wall object. So I'll go here and click, and now there'll be a wall there too, so I won't be able to walk through that. These ones I can never get to, so I don't really have to paint them red, but you can just for completeness. Or you could choose to leave those open in case you ever wanted to place some kind of a teleportation that pops up a character somewhere in the middle here, let's say, to get a prize or a treasure. Whoops, now I've made a gap here, so my character can go here. So I'll go ahead and fill that back in with a pencil and the gallery's wall tool there. And now I can click Done. Now that won't have changed anything visibly here, since I didn't change the graphics. I just changed a graphic that's off the screen right now. And so now that I have a background color and a tile map enabled, the next thing that I've got set up here as one of my enable code variables is the enable the baddie's home. Baddie is the enemy. I don't know why I called him that, but there you go. So I'm going to turn that to true. And you'll see a change on screen over here. This big sort of mushroom shows up. And if we look at what that actually changed in the startup, it's if enable baddie home is true, then it's going to call a function. So what you'll notice is that for setting up the background color in the tile map, that was a limited amount of code, so I decided to just stick it right here inside of this if block. The create baddie home has a little bit more code to it, so I decided to give it its own function. So we can see that if we zoom out and look at some of my other collapsed code here, I have a function called create baddie home. Excuse me, I'm going to get a sip of water. So let's bring this create baddie home block over here and open it up and see what's inside. Okay, it's nothing too bad, nothing too extreme, but there it is. We've got 3 blocks that create a sprite that's called baddie home, and I've set the sprite using the gallery. I've picked a big mushroom to be the home for the bad guy. And I gave it a type, which actually these should be capitalized. Pelly was just talking about that in their last stream. But I'm not actually going to use this feature here, but you will see it used with the enemy. So we can ignore what type of sprite that is for this case. Then we set that sprite's position on screen using the X and Y, or you can move the little crosshairs around. I'm going to leave that alone since I've placed it somewhere sort of specific there. And then I'm using Z-depth, which I believe we may have discussed before, but Z-depth is, if you think of the screen as having X coordinates, which are horizontal placements, and Y coordinates, which are vertical placements, Z is the coming towards you from the screen. Now, this isn't a three-dimensional game system, so why does that matter? Why do we need a third dimension? It's so that we can have objects go behind and in front of other objects. And so the Z axis is the screen towards you, with lower numbers, like starting with 0, at the very bottom level, right on the ground, and higher Z values are coming forward in front. And I think that might, I can't remember, that might go up to 255. I can't recall, but we'll probably take a look at that with another demo at another time. So that sets this little mushroom here. And then the next thing we're going to do is we're going to create a player character. So again, I'm allowing myself to turn these on and off as I test things and build things. So I'm going to go up here into my code and enable the player and set that to true. And what that means is during startup, the tile map gets built, that bad guy is home, the mushroom gets created, and then the player gets created. Enable player calls a function called create player. So let's minimize some of this code. We'll collapse that block, and let's bring the create player block over here. And let's open that up. Bring this over a little further. Some of these will get kind of wide, so they'll require some creative scrolling to get around. So what's happening when we get to this create player function? So the first thing is the sprite is created for the player, and this is one of the most elemental things in MakeCode, which is the very first category, very first block. Create a sprite of kind player. Now I've given it the name player1 instead of my player, and I've chosen a sprite from the gallery and then I painted on top of it. So I went and picked one of the existing sprites for this cat, and then I decided, since I had that beige ground, I wanted my cat to stand out a little more, so I used the paint bucket fill, and I filled it purple. So here you can see what would happen if I used green instead. So we can go through and fill some sections. So I've created my character as this cat. I've placed it using the X and Y axes values, and you can see this is actually closer to us than it is to the ground on Z depth. It's at a layer of 3. And then I've used this controls block. If we go into controllers, again, the very first block here, this is move my sprite with buttons. And so I have move my player 1. You can pick different sprites, but I'm moving player 1 with buttons. And what you'll see is actually if we take this block out for a second and run the game, I'll maximize this. You can see I can use the arrow keys to move the cat around the screen, but we have a problem, which is the tile map is wider than the screen, and my character is just heading off into who knows where. I could get lost. So what we're going to do is, rather than box in the character and limit their motion to the screen, we can instead pull in this camera follow sprite block. So that's over in, I believe it's under scene. And if we scroll down, there's this camera follow sprite. So you can do things like move the camera depending on gameplay events that happen, but we're going to go with this very nice and simple one, which is it just follows the sprite. So what that means is if we check out the simulator now, whenever the character gets to the center of the screen, so here you can see I'm at the far edge because we don't have any tile map left to go. But as we head to the right, since there is screen, it can start scrolling, same with up and down. So if we get down towards the bottom, eventually the camera stops moving so we don't see off into darkness where there is no tile map. Okay, so that camera follow works really nicely. You can just think of it like a camera overhead that's always tracking with the character, so long as it doesn't run out of room. And I'm just using the keyboard keys, but you can also use this joystick in the simulator if you want. That even allows for diagonal moves, which is nice. Okay, and now I'm just going to double check on my chats. Let's see. You know what? I haven't looked over at the YouTube chat in a moment. Hey everyone, thank you for stopping in. Hey Alvaro Figueroa, welcome. And Natman Allen, hello, thank you for stopping in. I'm watching the YouTube chat and Discord. Where'd you go, Discord? As well as the Mixer chat. So I'm not very good at multitasking, so pardon me when I do that. Okay, so now that we've created the player and we have the camera following them, let's see what happens next in our startup block. So we've got this enable baddie. So if we look up at my sort of debugging switches for turning on functions or sections of the code, if we turn on enable baddie, that means that when it starts up, it's going to call this enable baddie function here. So let's minimize this block and go find the create baddie. And the baddie is an evil puppy with red eyes, terrifying red eyes. So I've got the same create sprite, except I took a gallery sprite, added some angry looking eyebrows, and changed the eyes to red. So that's how you know it's the bad guy. And you'll see here the baddie position. I'm not doing anything terribly clever with this right now. I've actually just used the same numbers as the create baddie home sprite. We could have made a variable and had them both set to that, or used another method using classic tiles to position that. But here I'm just using the same value, except you'll notice the baddie has a z-depth of 2, and the mushroom I think was on level 0. So that means that the baddie will always be in front of that mushroom. And so right now, this baddie is actually, you can see it doesn't do anything. It exists, and it's in a certain position on X, Y, and Z in camera space. But if I move my player character, my purple cat here, nothing bad happens. There are no events caused by touching that evil puppy. So that's good. But let's change that, because that makes for not very exciting gameplay. So what we'll want to do is set up a event when there's a collision or an overlap between these two sprites. And so if we look in our code, I can minimize create baddie now. And let's look back at in the onStart block. I have a couple here that we can do kind of in either order. Let's take a look first at just what happens when the player overlaps that sprite of the bad guy. So I'm going to enable what I called gotcha. And if we enable gotcha, what we'll do, let's collapse this block again and take a look for this block right here, which is the on-sprite of kind player overlap, other sprite of kind enemy. So we didn't pay close attention to this, but if you look back at the create baddie block, and I'll open that up, you'll see that when the baddie sprite is created, it is of kind enemy. So you can think of this as a piece of data or metadata that this particular sprite, the baddie sprite, is tagged with. And then we can use that type of tag or metadata or kind, as we call it here in MakeCode. We can use that to filter things. So when sprites overlap each other, we can say, don't do anything if I overlap a treasure. Don't do anything bad, let's say if I overlap a treasure. Or if I overlap an exit to the level, we'll do something in particular. But we have something bad happen when we overlap an enemy. And so we can have multiple enemies. And so rather than have our character sprite only check to see each particular enemy, we can just lump them all together and have more efficient code that way by looking at anything that's tagged with enemy. And you can see there are different tags that come by default, such as player, projectile, food, and enemy. And then we can add our own as well, if we need them. So what happens now when our sprite that's of kind player is overlapping another sprite, which is of kind enemy? I'm going back and checking my debug switch, which says, is gotcha enabled? And remember, we just enabled that a moment ago. So that means anything inside of this block will happen when there's an overlap between the sprites. So first thing I'm going to do is I'm just going to splash the word gotcha up on screen. And that requires you to press A to leave that screen. And then we're also going to set the baddie position to go back to the home. Now right now the baddie is staying put, so that we won't see anything happen there, but let's test it anyway. Excuse me, I have a sore throat, so I'm going to grab some more water. Okay, so this time there will be a consequence to overlapping with the bad guy dog, which is this splash screen pops up that says gotcha. So to clear that, I have to hit A. Problem is, whenever I press A, I'm actually still in the exact same spot, so I'm going to continue to overlap. So what I'm going to do is I'm actually going to hold the down arrow key, and you can see I was just overlapping by a pixel. So if I'm holding the down arrow key, when I press A, it actually gives me a chance to get away and continue. So we wouldn't really use this for gameplay. We would probably have some other event, such as the character gets bumped away from the bad guy, so you're not stuck in a loop. That's a fairly common way to handle that. Or maybe the bad guy disappears when you get hit, or you die when you get hit, or you respawn somewhere else. So there's a few different ways to handle that. You can also use health points to reduce your health upon contact rather than just simply get sort of a final consequence when you contact. But to keep things simple, we just have this gotcha that pops up, and I can hold an arrow key to get out of there to proceed. So now what we're going to get to is the real original question, which is how do you have that enemy not just sit still. So you've got options such as enemies that patrol. So it's typical in video games to see a character that maybe is just marching around a certain path. And maybe they just have a locked timing and a locked path, or maybe they have some randomization in that. But that's really nice for stealth games in particular, where you can watch and wait till a character's around the corner and then run past. Some games, like in the Mario games, there's just simple timing with fireballs going up and down. You just have to jump at the right moment. But what we want to do is something a little more sophisticated, which is have a character that will notice us when we get too close and then start to follow us. And if you think about ways that you could do this, you might start to think about having a bit of math that calculates the vector between where the bad guy is and where the good guy is. And when that is within a certain distance, the character will start to move on a vector towards you, so it'll follow you. And that might be a really cool experiment or exercise in figuring out that math. However, it's not necessary in this case because there's a block that does that for you. So if we look now at our on start block and open that up, I'm going to turn on this last thing, which is enable the follow, set that to true. And I'm also going to turn off the gotcha for now, just so that there's no consequence and we can just test this. So what happens when I set enable follow to true? There's not a block here in startup, but there is a game update block that we haven't looked at. If we take a look in here, what's going to happen? Let me clear things up a little bit, move things away. So what's going to happen with this block is, whoa, there it is. If my debug variable is set to true, then it'll do everything else that's inside of this code. So we can ignore that and just look at what's inside here. So what I'm doing, this is a big complicated chunk right here. This is, whoo, that's long. This is what I'm using to determine when I'm a certain distance away from the bad guy. And so let's take a look at that, and I'm going to actually move the simulator out of the way so we can zoom in on this. So what's happening is I have a variable I'm creating called enemy distance. And the way I'm figuring it out is this big long thing, but let's break down what this actually is. So the first chunk of that, let's go right here. I'll explain what I'm trying to do first and then talk about how I'm doing it. What I'm trying to do is say if the difference between the X position of the two characters and the difference between the Y position of the two characters is less than a certain number, then we're going to trigger the character following you. So this essentially sets up a radius around the character where we're safe, and then when that number becomes less than, in this case I think I have it set to 70, when it's less than 70 pixels on screen, then we're going to trigger this follow animation. So what I'm doing is we could simply say if the character X minus the character Y, and if the character X and the player, I should stop saying character. If the player and enemy X's and the player and enemy Y's are added together and equal less than 70, that means we're close up. The thing is, I can get into some weird math if I'm not careful about how I subtract which one from which one, because we can end up with negative values. So the way I'm solving this is inside of math category, there is a min and max block. And so what I'm doing is saying if this allows me to figure out which one's the bigger of the two. So if I compare the X position of the player and the X position of the enemy, take whichever one of those is the bigger one. And so that's going to give us initially, since on screen the character is to the left, that's a smaller number on X, and the enemy is to the right. So that's the bigger one. So essentially what that's going to boil down to is it's going to solve this maximum question and say, well, the baddie has the bigger number. So we'll take the baddie's X, and then we repeat that same thing, and we'll say from the baddie X, we'll subtract the player 1 X. We'll add that to the exact same process for Y. And so what I've got actually to help understand that is this block, this console log value enemy distance, whatever that math came out to be. So let's take a look at that. If I open up the simulator down here, the console for the simulator, and start moving, you'll see right now the character, the maximum of the player and enemy X plus the maximum of the enemy and player Y is equal to 98. That's the distance between them. So you can imagine a circle with a radius of 104, 92, 78. Oh, we got too close. So that is how we're calculating when we get too close. So let's go back. We'll close that. And then we'll see what happens when we get too close. Something clearly happened because the evil puppy started chasing the cat. So when we are setting this enemy distance value, it's going to be initially greater than 70 just because I've spaced their starting points away. But on game update, that's what this block is. This is every tick internally. So this happens a gazillion times a second. That's not a word, I know. But it's a very, very high rate, the game's internal clock. I don't know what it is, a millisecond or less. Probably less than a millisecond. Gotta be, right? If you know, write the answer in the chat. That would be helpful. So when the enemy distance value is less than or equal to 70, then we'll do whatever is in this block. And what that block has is set baddie to follow player 1 with a speed of 60. So that one, I believe, is in sprites. And it's right here. It's called set my enemy follow my sprites. That makes it clear, this default name, what's going on. So that's setting my enemy. I changed that to be the baddie. Will follow player 1. And I set the speed to 60. Now, you'll notice I got away. And that's because my top speed is 100, or velocity is 100, and the yeah, I guess probably speed's the better term for it. So my character's top speed is 100, I believe, or 120 by default. And we can change that, but I've left the default in. And then I just set I tuned this, I played with it a bit, and I said, yeah, if the bad guy goes at a rate of 60, then they can catch me if I'm not careful. If I bump into a wall or something, they're catching me, but I can get away, so I'm running faster. Okay, so that's part one of that formula of what's going on. And the other thing is, what happens when that distance is greater than 70? So I've made my lead far enough, I've gotten far enough away. Then I'm just setting my baddie to go back home. And this is sort of an unconventional way to do this, but if you look over here, you'll see the puppy's trying to get back home. It's getting blocked by, whoa. Okay, there we go. It was getting blocked by a wall, but now if I come over here and look, the puppy is just staying at that sprite. So since it's a separate sprite, it was a convenient way for me to reuse the same concept and just say when it gets bored of following me, or I've beaten it, I've gone faster than it for long enough that I've gotten away, then it just tries to head back home. When I get within that 70, whoop, here it comes. It's after me. Now remember, we don't have any consequence right now to getting caught. Oh, there he goes. We can kind of follow him at a distance and see him try to head home. Oh, he got stuck. Woo! This actually might be kind of fun for a game mechanic where you're trying to get someone to follow you intentionally rather than trying to get away. Let's say we're trying to lead this puppy somewhere specific. Maybe we want him to head to a swimming pool or something because it's hot. That's another way that you could use that mechanic. So if we so if we get away far enough, it just tries to head back to the home. And you can imagine you could also add in other elements, things that characters are trying to follow. You could even use invisible sprites. So if you had some objects that were just moving and our bad guy was trying to follow that, when it got close enough to follow you, it might then find another invisible sprite. So you could set up little almost enemy AI types of patterns where the bad guys follow little routes to walk around until you draw them off of that. So if we look at that, why don't we take a look now at this fully in action running on let's see if I can get this to upload to my arcade. Oh, there we go. Let me switch cameras for you. So I've got my Pygamer here, and I think I need to set my brightness. So if I hit the select, we can head over to darken that quite a bit. That's pretty good. That looks pretty good. So let's hit select again. And I'll try my best to hold this in a way that you don't see all that screen moire action. And here I go. I'll let this puppy follow me. Oh, gotcha. Okay, so I enabled the final element there, which is that gotcha happens. And you'll notice this time when I get caught and hit A, the puppy has gone back. So it goes back to that home when we get caught by simply resetting its XY value. And so it just jumps right home. So as I hit A, puppy's gone. Whoa! This could also be a fun time-based game, like how long can you spend making this puppy run around and not catch you? How long can you play keep away for? Is another game element that can be fun. So if you look in the code here, let me go back to my start block, and I'll enable that final element, which I had enabled on the game version. I had downloaded that earlier, so that's why it looked different. So if we turn this true, okay, now that's gonna gotcha us. So let's look at what gotcha does. Rather than splash gotcha, we can do some exciting, fun stuff. I like to do things like shake the camera, have an effect get created, end the game. What if we do that? How about we'll set up a... Let's see, I believe that's under info, isn't it? Info, we can do, I think, set the change life by -1 and set the game, the life initially to 1. I can't remember if there was just a straight up end game. Maybe that is in game. Game over, okay. Let's use that. So rather than splashing gotcha, I'm going to delete that block. Game over, lose. Okay, so it's going to be mad at us. Watch this. Oh, tricked you. There we go. We lost the game. So that's a typical game mechanic you'll see in some of the tutorials in MakeCode games, is to set up a score that's just constantly increasing, or a timer that's counting down while this is so it gives you just a certain amount of time, so you can limit it, like how long can you stay alive or how many points can you gather. So if you look in info and game, you'll find a lot of items here that are useful for adding some gameplay to this. If I want to be a little less final, then this game over lose, let's get rid of that. We can do a, how about a camera shake? So I believe that's under scene. We'll shake the camera and lose some points, let's say. So let's go to info, change the score by 100. I don't have any scoring going on other than that right now, but let's see what happens. Okay, so you see, I added 100. I gained 100 points. Okay, every time the puppy catches us, we gain 100 points. So you just leave it right there. And we got that nice little camera shake in there. So those are just a couple of ideas on things you can do, but I hope that is helpful and answers the question. At least one way of answering the question is, how do I actually have enemies that follow me? So that, like I said, there are ways to do it, just automated paths, but this is a little bit more of like an intelligent enemy who notices when you get too close. And I'm a big fan of stealth games like Metal Gear Solid and what's another example? I was like Assassin's Creed, or what were the Sam Fisher games? Splinter Cell. I love games where you're sneaking around, creeping around, trying to avoid getting seen. And so you could use a mechanism like that, where maybe it's taking into account other objects, maybe hidden objects being in the way. If the distance are close enough, but there's an object there, we don't get seen. So there's a lot of ways to expand this into some pretty sophisticated gameplay. But as you can see, it doesn't take too much to set up a system like this, particularly with this wonderful block right here, which is the follow block, which makes so much of this very easy. It just takes a block. So that is it. I'll have a look in the chat and see if there are any questions. I've been keeping an eye on a couple of them. Let's see, in the Discord, there was a question about the Circuit Playgrounds. Yeah, Circuit Playground Express in MakeCode. I guess there was a live stream where they were using the simulator. Yes, thank you. You know what? I should always keep an eye, because on the Mixer chat, Jack in the Xbox, I just finally noticed you've changed your name, haven't you? Or maybe it was always the Xbox. Jack in the Xbox said, game over block. That's what I was looking for, yes. And Cedar Grove says it's like proportional mass gravity. All right, yeah, I guess that's right. That is how you would figure out something like gravity with the greater than objects adding together and equal less than when we get close enough like this. All right, well, I think that's all the time I've got for today, or all the material at least. I'll wait around another second or two to see if there's any other questions in either the Discord or the YouTube or the Mixer chat. Let me know. And please let me know over on the Adafruit Discord. That's adafruit.it/discord. You can go to the MakeCode channel there, or the live stream channel. And let me know if you have any things that you'd like to see, or questions that haven't been answered by this. It could be MakeCode Arcade, could be MakeCode for Circuit Playground Express, could be microbit MakeCode. Those are the ones that or Maker MakeCode if we want to use some other hardware. We've got a lot of different directions that we can go. So let me know if there's something you'd like to see. All right, well, thank you again for stopping by for Microsoft and Adafruit. This has been MakeCode Live with me, John Park, and I will see you next week at this time. Bye-bye.